We're going to look at organic chemistry, and we're specifically going to look at alcohols. And there is a reason why the OH is in capital letters here, and we'll see that in a few slides' time. Our learning intention is to explore the structure, nomenclature, and properties of tetrahedral carbons, and we're specifically going to focus on alcohols. So, as I said, we're looking at tetrahedral carbons, and I've already discussed the meaning of tetrahedral in our chloroalkanes video. So what we're going to focus on in this video is we're going to focus on the alcohols. So as I said at the start of the video, there was a reason I had the OH in capital letters in the name, and that's because alcohols form when one or more of the hydrogen atoms in an alkane are replaced by a hydroxyl group. Now, a hydroxyl group is an OH group, so that's why the OH is in capitals, is to help you remember. So I think it's important that we identify what a functional group is first. A functional group is an atom or group of atoms responsible for the characteristic properties of an organic compound. So our functional group of our alcohols is OH, and that is the hydroxyl group. Now, it does have a V shape, and we've discussed that in bonding. So that basically means that we would have an OR group, which would be your alkyl chain attached to your oxygen, attached to your hydrogen. So as you can see, we have that V shape that we're looking for. So as we've done with our hydrocarbons and our chloroalkanes, it's important to understand how we can name alcohols. So with an alcohol, you identify the longest continuous chain of carbons. The important thing here is that you change the ending of the parent alkane from E to OL. So you remove the E and you add OL. Then number the carbon chain starting from the end that gives the hydroxyl group the lowest possible number. So even if there's substituents, you must ensure that it's the hydroxyl group that gets the lowest possible number. Then indicate the position of the hydroxyl group and any substituents that you may have, and you assemble the name. So here we can see we have an alcohol. So step one is to identify our longest carbon chain. So I can see 1, 2, 3. So there's 3 carbons. So I know that this is going to be prop. Now, I would say propane, but I know it's an alcohol because I can see my OH here. So what I do is I remove the E and I add OL to make it propanol. Step 2 is to number the carbon chain. Now there's 2 ways you can number the carbon chain. You can number from left to right, 1, 2, 3, or right to left, 1, 2, 3. Now you need to pick the numbering that gives the carbon with the OH the smallest number. So I know that that is numbering from right to left, so I'm going to remove these numbers here on top. And I know that the hydroxyl group then is on carbon 1. So it's on carbon 1. So I can assemble the name now, and it is prop and 1 all. So it's very similar to how we would have named our alkenes. You indicate the position of the hydroxyl group in the middle of your name, so propan 1 all. So here's another one. So we'll take the same set of steps again. So 1, let's see how many carbons there is. There's 1, 2, 3. So again, we're dealing with prop, and it's not going to be propane, it's going to be propanol because it's an alcohol as indicated by the OH. So next I will number my carbon chain. 1, 2, 3, 1, 2, 3, and as we can see, the OH is on carbon 2 in both numberings, and there is no other substituents, so it doesn't matter. So it's going to be 2 all. So now I can assemble my name. It is prop and 2 all. So propan 2 all. So alcohols can be classified into groups based on how the hydroxyl group is structured or bonded within our alcohol. So the first classification group we're going to do is a primary alcohol. And a primary alcohol is an alcohol that contains one carbon that is directly attached to the carbon that contains the hydroxyl group. And an example of this is propan-1-ol, and as you can see here in propan-1-ol, we have one carbon directly attached to the carbon that contains the OH group. So basically what I do when I'm trying to figure out if it's a primary alcohol or not, I circle the CO and the H, and I look then at the bonds that are directly attached to the carbon, and I see how many of these bonds are carbons. So I can see here there's a hydrogen, and a carbon. So there's only one carbon bonded to the carbon that has the OH on it. So that would make me know that it's a primary alcohol. Now, for a primary alcohol, a very easy way to remember it is that your OH will be on either end of your chain. So if you look at an so a secondary alcohol contains two carbons that are directly attached to the carbon that contains the hydroxyl group. And an example there is propan-2-ol. So again, what I do if I'm trying to identify a secondary alcohol, what I will do is I will circle the carbon that has the OH attached to it as so, and then I look to see how many carbons are attached to that, and I can see there's 2 carbons attached to the carbon with the OH on it. So there's 2 carbons attached. So that means that this is a secondary alcohol. And a tip for a secondary alcohol to remember is that a secondary alcohol, your OH group will be in the middle of your chain of carbons. So next we'll look at a tertiary alcohol, and a tertiary alcohol is an alcohol that contains 3 carbons directly attached to the carbon that contains the hydroxyl group. And an example of that is 2-methylpropan-2-ol. So if we take a look at our 2-methylpropan-2-ol, if I circle the carbon with the OH attached to it, which is there, I can see that there is 1, 2, 3 carbons directly attached to the carbon with the OH, and that's what makes this a tertiary alcohol. So let's look at the physical properties of alcohol. So all alcohols are liquids at room temperature, and when it comes to their boiling points, alcohols have a boiling point that is much higher than alkanes, and that's due to the polar OH group giving rise to hydrogen bonding between alcohol groups. So we briefly touched on hydrogen bonding when we looked at our bonding chapter, and it comes into play here with our alcohol. So as you can see here, we have an alkane, and then we have an alcohol, so we've got methane, and then we've got methanol. So as you can see here, this H on the methanol can undergo hydrogen bonding with another H from a different alcohol molecule, and that's got to do with the bond polarity here of the OH. We don't have this here in our alkane, so that means that the alcohol has a higher boiling point as there is more hydrogen bonding. So the next physical property that we're going to look at is solubility. And the first thing we'll look at is the solubility of methanol. So in cyclohexane, methanol is not very soluble, and that is because methanol is polar and cyclohexane is not. So this first point here is linked to polarity, and if you remember with polarity, we said that like dissolves like. So a polar substance cannot dissolve in a non-polar solvent and vice versa. But methanol is completely soluble in water because it is polar. So like dissolves like there. So as an alcohol molecule gets bigger, the polar part becomes less significant. So the alcohol becomes less soluble in water and more soluble in cyclohexane. So for example, if we had pentanol is less soluble in water and more soluble in cyclohexane because a pentanol molecule is bigger, so the polar part becomes less significant in its solubility. If we look then at butanol, we see that butanol is soluble in cyclohexane and not very soluble in water, and that's because the carbon chain is longer, so the polar OH part plays less significance in its polarity. So that's what this last point says here. So let's take methanol specifically. The first thing I'd like to point out is the structure of methanol here. You can see that there is one carbon present, so that's where we get the name methanol. Now, methanol is a highly toxic alcohol. It can cause blindness, insanity, and sometimes death. It's added to industrial alcohol to prevent people from drinking it, and this mixture is often called methylated spirits, and methylated spirits will also have a dye added to it so that people are aware of its danger. Methanol, it acts as a denaturing agent, and if you're studying biology, you'd understand about enzymes denaturing with the active site changing shape. So basically, a denaturing agent, it renders a substance unfit for purpose without destroying the usefulness or application of the substance. And as I've said above, a purple dye is added to methylated spirits as a warning. If we look specifically at ethanol, we can see here we have our structure of two carbons, hence the word ethanol. And ethanol is produced by a process known as fermentation. And as you can see down here, we have our process of fermentation, where we have sugar or glucose breaking down to form our ethanol and carbon dioxide. And this process occurs with yeast, and the enzyme zymase in yeast is what catalyzes the reaction and pushes it to go to completion. Ethanol is used to produce drinks of higher alcohol concentration. But in order to do that, the fermented liquids must be distilled. So spirits, for example, which is whiskey, brandy, gin and vodka, they contain 40% alcohol. So they contain more alcohol than the likes of wines and beers. So use of ethanol, as we said already, they're used in alcoholic drinks. Ethanol can also be used as a fuel, and it can also be used as a solvent, as it can dissolve polar and partially dissolve non-polar substances. So this slide just shows the different percentage volume per volume of alcohol in different drinks. So to finish up alcohols, we should compare alcohols to water, and as you can see, both of them have polar OH groups attached. But alcohols also have a non-polar part, and the non-polar part is this methyl part here, the CH3 attached. Both alcohol and water can form hydrogen bonds between their molecules, and the hydrogen bonds will be formed at this point here in the alcohol that I've just starred, and it could be formed on either end of the waters that I've starred. Water is more polar and has a greater capacity to form hydrogen bonding, and as a result it has a higher boiling point than methanol or ethanol, and that again is due to its ability to undergo hydrogen bonding because it is more polar. So that's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.